Welcome to this video on the Automic Automation Google Cloud Run integration solution. In this video, we will explain the Google Cloud Run integration and what it brings to the Automic Automation user community. Google Cloud Run is a fully managed compute platform that allows you to run stateless containers, which can be invoked via HTTP requests or events. It's serverless, meaning it handles the infrastructure management, so you can focus on building and deploying your applications. Cloud Run abstracts away infrastructure concerns, such as scaling, networking, and security, allowing you to deploy your code in containers and have it automatically scaled up or down based on demand. Integrating Automic Automation with Google Cloud Run allows you to run Google Cloud Run jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating Google Cloud Run, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Google Cloud Run processes can then be synchronized with all other environments routinely supported by Automic Automation. Google Cloud Run's role is reduced to execute the jobs. All other functions, especially those about automation, are delegated to Automic Automation. This means that we don't have to log in to the Google Cloud Run environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run jobs in Google Cloud Run. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Google Cloud Run jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Google Cloud Run endpoint and login data, and a job template designed to trigger Google Cloud Run jobs. Let's assume we're automating for 4 instances of Google Cloud Run. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create a Google Cloud Run job in Automic Automation for each corresponding process in Google Cloud Run. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Google Cloud Run. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, these jobs can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Google Cloud Run integration is as follows. First, we download the integration package from the marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Google Cloud Run is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection, and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Google Cloud Run instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Google Cloud Run endpoint. Finally, we use the Google Cloud Run template job to create the jobs we need. We match these Automic automation jobs to the Google batch jobs, reference the connection object, and run them. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Google Cloud Run integration. The agent is included in the Google Cloud Run package, which we download from Marketplace. We unzip the package, which creates a file system agent/run/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcitx and set a minimum of 4 values: the agent name, the automation engine AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Google Cloud Run job. In our demo, we will create a connection object. Once we establish a connection to the Google Cloud Run environment, we will create a Cloud Run job. While there are 3 job types available: create run, create service, and run jobs, this demo will focus specifically on the create run job. We will demonstrate how to create, execute, and supervise this specific job type, as the functionality of the others is similarly straightforward. Let's examine the Google Cloud Run environment before we look into the Automic system. The Google Cloud Console provides an overview of our existing jobs. Within this environment, you will see several key menus. The Services menu represents your deployed applications or APIs. Each service runs a container image and scales automatically. The Jobs menu is used for background or batch processing tasks that do not serve HTTP requests. These can be triggered manually or scheduled. From the Google Cloud Run console, you can monitor running jobs, view execution times, and access logs. Similarly, for services, you can review logs and errors to troubleshoot your deployments. We are using the specific DOD01 Automic presales project for the demo. All jobs that run through Automic will appear in the console under this project ID, regardless of whether they succeed or fail. Let's move on to the Automic system. Here, we create connection and job objects with specific inputs that allow us to connect to Google Cloud Run. If we open a connection object, we must enter the most important field, the endpoint. It is the URL of the Google Cloud Run environment. Next, we specify an authentication type from the drop-down menu. 2 types are supported: VM metadata instance, which requires a service account email for authentication, like, for example, test@gmail.com. For this demo, we use the other option, service account key, where we must provide the input type for the service account. We can again select if we want to provide the input type through JSON, which requires us to enter the JSON payload definition, or through file path, where we enter the file path to the JSON file that contains the authentication information. We select file path here. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined and saved, we can create a Google Cloud Run create job. Here, We start by opening the attributes page and make sure you select the agent that corresponds to the agent name you configured in the INI file. Now we go back to the Create and Run Job page, and in Connection, select the connection object we have just created to connect to the Google Cloud Run instance. It holds the necessary information to connect to the Google Cloud Run environment. Following the connection input, the job requires the project ID, which is the ID of the Google Cloud project. We use the one we have already seen in the Google Cloud Run console. Optionally, we can define the location details, which is the region where our Google Cloud Run resources are hosted. The next field is the job name field, where we indicate the job's name. The Create Payload field lets us choose between the JSON file path field, where you can define the path to a JSON file containing the task attributes that we want to pass to the application. Make sure that this file is accessible from the agent machine. The JSON field, on the other hand, allows us to enter the JSON payload definition, which we can directly paste from the Google Cloud Run console or elsewhere into the text field. For this demo, we use a JSON payload. The next field is the Run Payload field, where we have three options: None, JSON file path, and JSON payload. We select None here. The final field is the Delete on Completion checkbox, which you can check when the job should be deleted from the local directory after it has completed. Once all the parameters are set, we save and execute the job. Let's switch to the Executions view. The Details pane shows the Remote Status field, which tracks the job status in the target environment. In our case, the execution was successful. The Details panel also shows an object variable called an execution name hash. It helps us clearly identify the specific job execution, which we can use for further analyses. Let's have a look at the reports. The first report contains all the information that the target system sends to Automic Automation when the job has been executed. This information is presented in a structured output, including execution details and results in JSON format. In other words, the information is presented in a way that is easy to break down and analyze for further use within Automic Automation. Let's check the file status on the Google Cloud Run instance. If you go to the job list, you'll see the job that we have triggered, and it has ended with the status succeeded. The next log type is the plog type agent log, which shows all the agent's actions step by step. It lists all the parameters used to run the job and contains the response received from the target system. That wraps up the demo on how Automic Automation can integrate with Google Cloud Run to run, execute, and monitor jobs. Thank you for watching this video.